So look at the roots, guys, for each graph. What do you notice about the x-intercept, okay, that has the odd multiplicity? And how about the x-intercept that has an even multiplicity? Let's go back really quick regarding our three graphs right here. So this first one, if you guys remember, we have an even multiplicity. Okay, remember, an even multiplicity is when we have like the power of 2 or the power of 4. So the power of 2 meaning that we write it out twice and it looks exactly the same. So that's an even multiplicity. And we talked about an even multiplicity having it bouncing off the x-intercept. Then the next two graphs, right, we have an x plus 8 to the third power. So if we write it out 3 times, that's an odd power. So in odd powers, as you guys can see here, it crosses, right? It crosses, it goes through the x-axis. Same thing with this one. This is a line. So a line meaning that we have a degree of 1. So the degree of 1, that's not even, right? So we're going to say, hey, that's going to be crossing the x-axis. So we are going to fill this out. It says, what do you notice about the x-intercept, okay, that has an odd multiplicity? Odd multiplicity. Oops. Let's see my pen. There you go. Crosses the x-axis. Then we have even multiplicity. Bounces. Okay, or we can say touches the x-axis. Okay, so let's review really quickly some of the parent functions and what it does. First, we have a linear graph, y equals x. So linear, guys, that means a degree of 1. Since we don't have a y-intercept, we will start at 0. Let's make one tick mark all the way around here. So we start at 0. The slope is going to be 1 over 1, and then you could do down 1, left 1 will also give you guys a slope of 1. So degree of 1, and as you can see, because it's the degree of 1, it crosses the x-axis, okay? It crosses the x-axis. Now we have a degree of 2 now, since we have a y equals x squared. So we are going to make like a couple of tick marks in here just to get an idea of where this will go. Okay, so when x is 0, y is 0, when x is 1, 1 square is 1, when x is 2, we're going to square that, that's 4. And as you guys already know, this makes a U shape and it is symmetrical. Okay, so as you can see here, degree is 2, it's touching the x-axis, aka it bounces off the x-axis. Then we have a degree of 3, okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. On the y-axis, we are going to scale it by 2, okay, so let's go 2, 4, 6, as long as my pen works, there you go, 8. Okay, then -2, -4, -6, -8. So when x is 0, 0 to the third is 0. So your degree, guys, is 3. When x is 1, 1 to the third is 1. So I'm going to go really close because we rescale it. The y-axis, okay, oops, undo that, undo. Only the y was rescaled, so I want to make sure. Okay, so here we go. When x is 1, y is up. When x is -1, y is down, -1. Then when x is 2, remember we only rescale the y. Y was 8 because 2 to the third is 8. And then when x is -2, -2 to the third is -8. We know that this is a snake pattern. So And again, degree is 3. It crosses the x-axis. Now, degree of 4, we have not studied degree of 4, but that's okay, guys, because it behaves the same way as a degree of 2, okay? Because any negative number, when you raise it to an even power, it will be positive. So let's go rescale. We don't need to rescale our x-axis, okay, but we are going to rescale a y-axis. Okay, so 2, 4, 6, 8, 10, and then go off the grid if needed. Similarly, okay, so this is negative 10 down here. All right, let's go. 0 to the 4th is going to be 0, right? 1 to the 4th is 1. Okay, negative 1 to the 4th is still positive because it's an even power. Now we have 2 to the 4th. Guess what happened when you go 2 times 2 times 2 times 2? This is 4, this is 4, 4 times 4, that's going to be 16. I only have 10 right there, so I'm going to go off the grid. So imagine 16 is up here, okay? And then negative 2 to the 4th, again, is going to be all the way up there. So we are going to see that, hey, it's kind of similar to your degree of 2. Because when you have an even power and you square everything, 4th power everything, that would be positive. So again, even power, let's pinch it all in, okay? Even power, it bounces off. Odd powers, it crosses, okay? Now let's do the summary of the end behavior because it's really important, okay? End behavior is matched to the degree and the sign of the A value, okay? So now let's look at this one. A value for this one is 1. It's positive. A value for this one is also 1. It's also positive because these are the parent function. So of course, all the parent functions will have no A value besides 1. So what happens when we have a positive A value, right? Your odd degree, as you can see, so I'm trying to pinch it in so you can see it. So here's your odd degree. We got odd degree here, 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 here. When it's positive, they are exactly the same, right? In terms of it starts on the bottom and it ends on the top. So let's go look at the odd degree. Okay, so it starts on the bottom. I'm gonna kind of make a sketch really quickly. So i.e. y equals x to the 3rd. So it's okay. So when x is negative infinity, when x is approaching negative infinity, which is, remember, which is over here, y is going down, and down means that's a negative infinity. When x is approaching positive infinity, remember, positive infinity is on the right side, so y is going up. So when it's an odd degree and A is positive, okay, as you can see, the x and the y are kind of the same, right? As x is approaching positive infinity, y is also approaching positive infinity. Now what happens when we have an even degree? Y equals, i.e., let me see as soon as my pen works here. Come on, pen. There you go. Okay, so i.e., y equals x squared. We just got done graphing this, so I'm just going to sketch it out really fast. Bam. Okay, so when x is approaching negative infinity, meaning that when x is on the left side, what's going on with the y value? So when x is on the left side, y is going up. When x is on the right side, y is also going up. So for an even function, guys, they're both going up for the end behavior, right? So up and up. Now, what happens when you have an odd degree? And A is negative, like i.e., what if I give you y equals negative x? Isn't that the slope of negative 1? So negative slope goes like this, okay? So when x is on the left side, y is actually up. So when x is on the left side, y is up. But when x is on the right side, y is going down. So that's a negative infinity. Similarly, guys, when we have an a that's being negative, so i.e., it's going to be y equals negative x to the 2nd power. Well, isn't that opening downward? Yes, you are right, okay? It's opening downward. meaning that both y values are going to be down and downs. Doesn't matter if x is positive or negative. So negative infinity and negative infinity. So guys, if you can sketch a really fast graph of these odd degrees and even degree, a is positive, a is negative, then all of your end behavior are really going to be